Today we're going to talk about special parallelograms. So I put on here the quadrilateral family tree. We started with quadrilaterals, we talked about kites, we talked about trapezoids, we also talked about isosceles trapezoids. Yesterday we focused on parallelograms. Today we're going to talk about rectangles, rhombi, and squares. Okay, so keep in mind they are all parallelograms, right? The rectangle is a parallelogram, the rhombus is a parallelogram, the square is a parallelogram, but they have extra things about them that are special. So we're going to start first with a rectangle. So by definition, a rectangle is a parallelogram with four congruent angles. Okay, now since then we've learned a little bit more. We learned that every quadrilateral, if you add up their angles together, will equal 360 degrees. Okay, so now if I know all four have to be the same, when I divide that by 4, I get 90 degrees. Okay, so that tells me that a rectangle has 4 right angles. Again, this is one of those things that you knew, but I don't think you truly understood why. But it's really because we have 4 congruent angles by definition. And then when we take 360 divided by 4, that's what makes it specifically 90 degrees or right angles. The diagonals of a rectangle are congruent. We're going to talk about that here in a second. The diagonals of a rectangle also bisect each other. Now, this is true because it's a parallelogram, right? That's one of those properties of parallelograms. So let's explore a little bit the fact that the diagonals are congruent. So let's see, I have a rectangle here. I'm going to draw in my 2 diagonals. And we have lots of triangles here. This is actually an overlapping triangle proof. We're going to focus in on this triangle here and this triangle here. All right, these are my 2 overlapping triangle problems. Now, yesterday we learned that opposite sides are congruent. Now, again, because we're focusing just on those 2 triangles, I'm only going to mark these 2 sides as being congruent. Technically, the top and the bottom would also be congruent. Now, focusing again just on these yellow and green ones, I notice they share this side. We also know because it's a rectangle, we have 4 congruent angles. Now, they're right angles, but the fact that they're congruent is really all we need. So because of all that, then the yellow and the green triangle are congruent because of side angle side. What that means for us then is that the diagonals, which is the hypotenuse of each of those triangles, those are congruent. Okay, now here's the extra thing that's pretty special. Because the diagonals are congruent and they bisect each other, that means then all 4 of those pieces have to be congruent. And what ends up happening is we end up creating 2 sets of isosceles triangles. So here's one set of congruent isosceles triangles. And then on the left and the right, we have another set of congruent isosceles triangles. All right, so here's our properties. We have 4 right angles. The diagonals are congruent. The diagonals bisect each other. So let's try a couple of problems here. So in quadrilateral RSTU is a rectangle. If RV is 3x plus 2 and SU, this whole diagonal, is 7x minus 4, we want to find x. So keep in mind, because the diagonals are congruent and they bisect each other, all 4 of those pieces are 3x plus 2's, right? So to get all of SU, that means we'd have to have 6x plus 4 to equal 7x minus 4. So really that was 2 of the 3x plus 2's, right? That's how I got that. All right, so now I can subtract 6x from both sides. I get x, add 4 to both sides, and we get 8. All right, so in this case, x is equal to 8. Okay, in this example, we're going to look at some angles. So it says we have a rectangle again, so I know I have right angles. So I know that there's a right angle, which means I should be able to add those 2 expressions together to equal 90 degrees. So I'd have 8x plus 10 would equal 90 degrees. Subtract 10 from both sides, I have 8x equals 80. Divide by 8, I have x equals 10. All right, so now that allows me, then I can actually find the measure of those angles. So if I plug that in, this would give me 10 times 5 is 50 plus 8, that's 58 degrees. 3 times 10 is 30 plus 2, that gives me 32 degrees. Now, to get y, this angle right here, keep in mind, we do have parallel lines, right? So these two angles have to be congruent because they're alternate interior angles. So that tells me that 6y plus 2 has to equal 32. Subtract 2, you get 30. Divide by 6, we have y equals 5. All right, so now let's explore the properties of a rhombus. Okay, so properties of a rhombus here. A rhombus is a parallelogram with 4 congruent sides. So it's still a parallelogram, still have all those properties, but we also have 4 congruent sides. All right, so we're going to talk about all these and then we're going to kind of prove them. So the diagonals of rhombus, they're going to be perpendicular. And we're going to prove that in a second. They're going to bisect each other. So the diagonals bisect each other. Again, that's because they're parallelograms, right? It's a special parallelogram. And then the last one, it says the diagonals of a rhombus bisect the angles of the rhombus. Okay, so we're going to talk about the first one and the last one. I want to kind of explore that a little bit. So let's go ahead and make ourselves a rhombus. All right, and now remember, because it's a rhombus, we have 4 congruent sides. Okay, I'm also going to go ahead and draw in my diagonals. Now, because this is a parallelogram, I know that the diagonals bisect each other. Okay, so what I want you to notice is we actually have 4 congruent triangles here. We have 4 congruent triangles. So, and that's just by side, side, side. So by CPCTC, I know that this angle, this angle, this angle, and this angle are all going to be congruent. I know that this angle, this angle, this one, and this one are all going to be congruent. Okay, now I can say the same thing for all the ones in the middle. But keep in mind, even if these two are congruent right here, okay, that means they have to be congruent and they're supplementary. So that means each one of them has to be 90 degrees. So this is how we have diagonals that are perpendicular, and these diagonals end up bisecting the angles. Now keep in mind, this whole angle is still congruent to this whole angle, right? But then it's also bisected now by the diagonals. All right, so let's try a couple of examples with that. So it says use rhombus L, M, and P and the given information to find each value. So find y if the measure of angle 1 is y squared minus 54. So because it's a rhombus, I know I have a right angle here. All right, so I know that y squared minus 54 has to equal 90. If I add 54 to both sides, I get 144. Take the square root, I get y equals plus or minus 12. Now, a lot of times in geometry, we can only have positive values, right? But because we end up squaring it, positive and negative 12 squared will still give me that positive 144. Okay, so this is a case where it's okay to have plus and minus. Next one, it says find P and L. I want to know this angle right here. If MLP, angle MLP, this whole thing is 64. Okay, well, that's 64. This whole angle has to be 64. And I know that diagonal bisects that big angle. So that's got to be 32 and 32. So the measure of angle PNL is going to be equal to 32 degrees. All right, so our last shape here is a square. So a square is a parallelogram with 4 congruent angles and 4 congruent sides, which means it's a parallelogram that's both a rectangle and a rhombus. So all these properties should be familiar. The diagonals of a square are going to be perpendicular. That's from my rhombus. The diagonals from a square are congruent. That's from my rectangle. And still, the diagonals of a square are going to bisect each other. Okay, that's because it's a parallelogram. Okay, so here's kind of the neat thing that happens with squares. So here's my square. I got my diagonals here. Okay, now keep in mind we have 4 congruent sides, right? And we know that we have right angles. Now the diagonals are congruent and they bisect each other. So we have 2 tick marks on all of those. All 4 of those pieces have to be congruent. So this ends up being a right isosceles triangle. We know each corner of my squares is 90 degrees. And we know this diagonal bisects it. So each of these angles here has to be 45 degrees. The nice thing about a square, there's not a whole lot of thinking, right? You don't have many choices there for your angles. Okay, so I know this was a lot to kind of put together. So what I made for you is this graphic organizer. Well, I found the graphic organizer. I did the rest here, but I put in check marks for everything that's true. So for a square, all of those things are true. For a rhombus, all of those things are true. So keep in mind here, if it's true for a parallelogram, it's true for all the special parallelograms, right? So you'll see that once you have a parallelogram, it's all the way across. I also put some points of clarification in here for the ones with the purple boxes. So opposite sides are parallel. That's only true for one pair of sides on trapezoids and isosceles trapezoids. So I put some clarifications there. But I did also upload this as a PDF in your notes or in Google Classroom. So your homework for today and tomorrow, so this is kind of a double assignment, is going to be, obviously you just watch this video and now you're going to work on that assignment that has all 4 types of special parallelograms.